So, well done, Hattie, on getting one of those assignments through to me. Then one of the mechanics ones, the first mechanics, that was excellent. You did very well in that, as you know, and I've sent you through the answers and stuff. So, and I was just saying to Tom before we went live, I am wary of the fact that Mr. Kent and I are pushing you very hard, and we're getting well into the upper sixth stuff, yet still expecting you to catch up on the assignments that sort of fell through the cracks as we went into lockdown. So, do your best, but nobody's going to get in trouble if they don't get any done. But I just feel that if you can get up to date with the lower sixth assignments, it will make you feel good. The other thing is, just in our maths meeting a couple of days ago, I think the school's policy is going to be, all you guys, when we return in September, there will be some sort of testing. Um, and nobody knows the details yet. So the idea is there will be some sort of progress test at that point. So, that might be another incentive just to try and get up to date with those assignments when you can, just as part of your revision of everything we've done so far. Right. Okay. So just a little bit to look at today. 3.5 is the sum to infinity. So obviously, if each term is getting bigger than the last one, okay, it's our diverging series. And of course, because each term's getting bigger and bigger and bigger, you can't go and sum and just sort of say how much they would be forever, because obviously the terms are getting bigger and bigger and bigger. However, if you've got a converging series, so the numerical value of r is less than 1, it could be plus or minus, because you can have plus plus plus, you could have plus minus plus minus. So it doesn't matter whether it's plus or minus, but if the numerical value is less than 1, because each term is getting smaller and smaller and smaller, in time, effectively, the terms just become negligible. So provided the modulus of r, the numerical value of r, is less than 1, the formula that we're familiar with just simplifies down to a very straightforward formula. Okay, the sum to infinity, where you've got a converging geometric series, i.e. each term is getting smaller and smaller and smaller, is a over 1 minus r. So it really couldn't be easier. Okay, that it's given in the formula book. Now, you're never going to get a question at A level that just gives you a and gives you r and asks you to sum to infinity. Clearly, that's sort of first form sort of standard of maths. Okay, what they will do, they will dress it up in a bigger question. Okay, so this simple example, you're very familiar with part A. So this is the fourth term and the seventh term are given. Remember, you've got this difference in 1 between the nth position and the power of r. So for the fourth term, it's r cubed. For the seventh term, is r to the 6. So this is what you've been doing up to now. So you've got a simultaneous equation to solve. Then clearly for part B, you're just using this new formula. You've worked out that r is 0.6, a is 5. You just sub in to say that as you sum to infinity, the total is just going to be 12.5. Easy peasy stuff. I don't think there was anything new for example 16. Okay, you're just finding the possible values of r. So you've got two bits of information. The sum of the first 4 terms is 15, so you're just substituting in to get equation 1. The sum to infinity is 16, that's giving you equation 2. So 2 equations, the 2 unknowns of a and r, so you can just solve the simultaneous equation. And then once you know r, they tell you it's positive, you can just work out what a is just by subbing into the same equation. Is that it? Literally, that was it. Gosh, hardly worth bringing you across to a meeting for that, was it? So yes. So if you could just try and do exercise 3E, I would really not bother too much with the earlier ones, and just get on to the. I mean, it's quite a long exercise from memory, but they're very quick. The questions. 6 is nice. That's sort of approaching the recurring decimal type question from a different viewpoint, which is quite nice. So dot around that exercise, please. As I said, it's quite long. I see you tomorrow, so I will we'll just go live tomorrow, just while I introduce the sigma notation tomorrow. We then have a bit of breathing space until I see you the following Wednesday. So I don't think it's realistic to expect you to have got all of this exercise done, exercise 3E done before tomorrow. But if you really take the view that you need to try and get 3E and 3F understood and done what you want to do of it by Wednesday, I think that's a little bit more realistic. So thank you for joining me, you two. I don't know if others have joined since. And yes, so we'll just go live tomorrow, period 2, for I'll introduce you to the Sigma notation, and if you have been able to make a start on 3E, that would be great. Okay, guys, thanks for joining me. Have a good afternoon. I'll see you guys tomorrow. Oh yeah, lots of you there now. That's nice. Okay, cheers, guys. Bye.
Thank you.
Thank you.
Bye.